So far, we have learned about tensors, gradients, autograd, and randomness in the last video. Now it's time to handle real data, because without efficiently feeding your data into models, everything else falls apart. And that's exactly where PyTorch's dataset and DataLoader come into play. Let's break this down first, and then we'll jump into working code example. Imagine you're training a neural network on thousands of cat and dog images. You could manually load them all using list directory, process them using pillow, and feed them batch by batch. But that would be painfully slow, unscalable, and inconsistent. PyTorch solves this problem with two elegant abstractions: dataset and data loader. Dataset is how the data is stored and fetched, and data loader is how the data is patched, shuffled, and fed to the GPU memory efficiently. Let's see how dataset and data loader works internally. Dataset defines two functions, length and getItem. Length tells us how many samples are available. GetItem provides utility to fetch one sample. On the other hand, data loader wraps the dataset and helps you shuffle data every iteration or every epoch. It also helps you load batches of samples, and it uses multiple CPU workers for parallel loading of data. Data loader also automatically pushes data to GPU efficiently. So in short, dataset defines what your data is, and data loader defines how your data flows through the training pipeline. Let's have a look at this with example. So first thing I'm going to do is create the notebook, and I'm going to name this dataset underscore loader dot tutorial. And as always, let's import torch. Let's check the version of the torch dot version. And then let's import the dataset and data loader utility. So I'm going to say from torch dot utils dot data import dataset and data loader. Now the idea here is to create a custom dataset that will return the square of the number. So I'm going to say class, or let's actually write our steps. So step 1 is create a custom dataset, and this is actually a comment. And let's create our class. So class, I'm going to name this square dataset, and let's inherit this with dataset class. Let's create a constructor for this. So init and self and length equals to 10. And if you remember from our tensor video, we can use a range function, which is pretty similar to Python arrange or range function. So a range, and let's pass in our length. Now then we can override the length function. Self, and let's return the length. Return length of our data. So self dot data, this should be dot data. Now similarly, we can override get item function as well. This will take in self, and let's take the index as well. Then x equals to self dot data using index, and y will be the square of x. So get item is the function where we are actually defining how to retrieve single sample from the batch. And that's it. So let's see what's going on here. So square dataset is our custom dataset class, and in it, or the constructor defines or prepares your data, and length function tells PyTorch how many sample exist in the dataset. And get item tells PyTorch or defines how to get one sample from the dataset. Now step 2 will be to initialize this dataset and create a data loader or initialize data loader for our dataset. So let's write step 2. Initialize dataset and data loader. Dataset equals to square dataset, and let's pass the length as 10 only. And then let's define data loader. Data loader equals to, we have to pass our dataset to data loader class and batch size argument. And I'm going to pass this value as 3. And let's pass this argument shuffle as true. And that's it. So what this data loader is doing, it automates batching, which breaks data into mini groups. In this case, that mini group is of size 3. Then it also does shuffling for us. So that's randomizing order each epoch, which is good for training because our model can generalize better and converge better. And then it takes one more argument of num workers, which if you set to more than 0, it loads data in parallel. And that's helpful for parallel loading of data. I'm not using num workers here, but obviously when we actually train our model, I'm going to use num workers as well to load data more efficiently. Now let's actually iterate through our data loader and see how does data look like. So I'm going to say step 3 will be iterate through batches. And let's see, for batch index comma x comma y. And let's use enumerate method. So we get index as well. Data loader. And let's print all the things. So I'm going to say print batch index +1 to get the accurate number. And let's print x first. And single quotation here as well. Now let's print y as well. So y. So that's it. Let's look at our data and see how it looks like. Of course, this should be within quotation. And let's rerun this. So this is what our data looks like. So data loader has automatically created batches. Data loader has grouped our data into batches of 3. So 3, 3, 3, and then last one as 1. So this is all done by data loader. And when you feed these batches into your model, data loader will make sure to change or shuffle them as well. And I can show you that if I rerun this, you see batches or the tensors or the values within our tensor has actually changed for every epoch. If I rerun this, you'll see values have changed again. So that's the beauty of data loader and dataset. Now, if you don't understand this or what exactly data loader and dataset is, I would suggest to rewatch the video. And even then, if you don't understand, in the next video, we'll extend this one step further and use real dataset or MNIST dataset and load it using data loader and dataset and do some transformation. So don't worry if you didn't understood or if it's too much as of now, because trust me, you'll understand this once we actually start working with the real data set. So with that, thank you so much for watching, and see you in the next part where we'll understand how to load real data set using Dataset and DataLoader, and how to perform some transforms and augmentation on our data. So thank you so much, and see you in the next part.